The video that I'm about to cover has done the rounds quite a bit, but I thought that I would pick it up because it provides a nice opportunity to talk about some stuff. You may have seen my previous video on Mitchell from Australia, and I was originally planning on doing one video to cover the previous topic and today's topic, but it just didn't feel quite right. So without further ado, I will hand over to Mitchell from Australia.
I'm Mitchell from Australia, and this is the end of SciManDan.
Yeah, this is the end, all right. The end of originality. That is both a comment on your use of the rather tired SciManDan and the fact that this video has been covered a lot already, so I can't exactly claim novelty myself.
Now, we've all seen star trails, and this is claimed to be caused by Earth rotating, which I've already thoroughly debunked.
No, you haven't.
Because when viewing stars in the inertial reference frame, they should not move.
Actually, all you did was demonstrate that you do not understand the concept of a reference frame. Now, I am not going to give you shit for that, as most people wouldn't know about this. But then again, most people don't upload your kind of nonsense onto the internet.
But rather than have a bit of humility and concede this is true, SciManDan has now claimed we can see star rotation from the ISS, which he is now going to have to concede that that is a fraudulent claim.
A fraudulent claim? Now, I have gathered that you are taking your science lessons from Nathan Oakley, but it also sounds like you're taking your legal advice from Anthony Riley. I think you need to scratch up on your understanding of fraud.
Because I'm about to show how fake this image is on so many different levels. But firstly, we do not even need to go into this image to prove that anything from space is fake. The Glober's goal here is to give us a red herring to argue if star trails are even possible from the ISS.
Wait, you are saying that it is the Glober's goal to get you to argue about whether star trails are possible from the ISS, as if that is a red herring to distract you from stuff you really should be arguing about. That really is an overinflated sense of self-importance there. Do you really think that they purposely created that image for you to argue about? As in, they actually consider you significant enough to give a shit? Oh yes, of course, I forget. You are part of that merry band of heroes who know the real truth, and you are the biggest enemy of the establishment. Get over yourself. I am going to insert my own little conspiracy theory here. Flat Earth is complete bullshit made up by the intellectual elite to keep idiots busy and out of the way and preoccupied with nonsense, so the rest of the world can just get on with solving real problems without you lot disturbing them.
Because anything from space is a second law of thermodynamics violation. Violating a natural law is not possible. Space is claimed to be a vacuum, and the air we breathe here on Earth would absolutely increase in entropy and fill the available space. So we already know that this image is faked, but the vast majority of people are not yet at this understanding.
So, natural laws can't be violated. Now, while it is correct that true natural laws can't be violated, that doesn't mean that what we understand the natural laws to be can't be violated. This is a key point in science. Now, when we discover a law, we try to break it to see how well it holds. If we are lucky, we just happen to observe stuff that appears to violate that law. For example, the orbit of Mercury violating Newton's law of universal gravitation. To say that these are the laws of physics and you absolutely cannot break them, you need to know that your statements describing these laws are correct. What we call physical laws are just statements about observations that, as far as we know, always appear to be true, until they are not, like the aforementioned universal law of gravitation, or the recent observations that appear to violate the Wiedemann-Franz law. The point is that although true physical laws cannot be broken, what we think the laws are could very well be broken. We just don't know. Our description of the universe is not infallible. Now, having said that, we are pretty confident that the second law of thermodynamics cannot be broken. Many physicists will even go so far to say that almost all the laws of physics are likely to be incorrect or incomplete apart from the second law of thermodynamics, but that is our understanding of what the law states. What flat earthers think of what the second law of thermodynamics states can definitely be broken. It is not because the second law of thermodynamics being incorrect, but their understanding of it being incorrect. Now, the second law of thermodynamics is a tricky beast. The Wikipedia page for it says that total entropy of an isolated system can never decrease over time and is constant if and only if all processes are reversible. Isolated systems spontaneously evolve thermodynamic equilibrium, the state with maximum entropy. Now, there are a few bits in that which we need to consider. First, we need to think about what an isolated system is. In physics, we generally use three types of system: open, closed, and isolated. For an open system, energy and matter can freely enter or leave the system, and it is pretty useless for solving problems in thermodynamics. A closed system does not allow matter to enter or escape, but can freely exchange energy with its surroundings. An isolated system does not allow anything, mass or energy, to enter or leave the system. So is the Earth an isolated system? Well, no. Energy flows in and out, and so does matter. So technically speaking, the Earth is an open system. However, the amount of mass coming in and leaving is negligible, and that allows us to approximate it as a closed system in certain applications. But we can never treat it as an isolated system, as the Earth receives and emits approximately 27.5 metric fucktons of energy every second. Our best guess is that there really is only one isolated system that truly exists, and that is the entire universe. Everything else is either an open or a closed system. However, closed systems can be insulated well enough such that they approximate an isolated system. Next, the second law talks about reversible processes, and this is the only one condition in which the change in entropy can remain zero if the system is not at equilibrium. So here we have something else that must be defined. A reversible process is one where a system can go from one state to another and then back again without losing energy. A classic example is a pendulum which is swinging. You have the pendulum raised away from the equilibrium position and then it has some potential energy. You let go and it starts swinging. Once it is at the bottom, it has converted all that potential energy to kinetic energy, but the total energy hasn't changed. It then swings to the other side where that kinetic energy is converted back to potential energy. The pendulum can then swing back to the original position and it still has the same amount of energy. In this situation, you had the pendulum going from one state to another and then back again without losing energy. The process is reversible. Well, that is in the idealized case. In reality, the pendulum loses some energy to its surroundings due to drag and friction, and this energy is lost.
3, 2, 1, 0. Physics works, and I'm still alive.
There is no such thing as a reversible process, at least not on the macroscopic scale. So as long as we are dealing with macroscopic systems, we can state the second law of thermodynamics as in an isolated system, the total entropy will always increase over time unless it is already at a maximum. But, of course, we must also ask the question as to what entropy actually is. But before we do that, we should really take a moment to consider something that may not be too obvious. I just want to highlight that the second law is, well, a law of physics, which, well, duh. But I say this because there is an important distinction between a law and a theory. Theories talk about mechanisms and how stuff happens and why. Theories provide explanations of the laws of physics. A physical law is just a statement about an observation that always appears to hold true. It does not talk about mechanism, and this is important. In context of the second law of thermodynamics, it is actually incorrect to say that gas expands because entropy increases. What actually happens is that the entropy increases because of the gas expanding. I always prefer intuition over maths, or at least to start with intuition first. When it comes to physics, maths is useless without intuition, but then again, Intuition is also useless without maths. So macroscopically, the most intuitive description of entropy is the energy that is no longer available to do any work. In mechanics, we define potential energy as the energy that is available to do work. So we can restate the second law of thermodynamics as the amount of potential energy in a system must decrease with time. Now, I like this statement a lot as it is a really simple description of the universe. However, you have to recognize that there are lots of different types of potentials, and as always, you have to define your system correctly. But in short, this is the principle of minimum energy, and it states that everything will go down to the lowest accessible energy state, and due to frictional forces and such, it will eventually stay there. Take the pendulum example I used earlier. It starts off on one side at some height and then swings to the other side, but because of friction, it won't quite reach the same height. The amplitude of the swings decreases until eventually the pendulum just hangs still in the middle. As for my earlier comment about defining your system correctly, if you just consider the energy of the pendulum itself, you will run into trouble. You have to include the air around the pendulum, the building, and basically the whole universe. The same principle also applies in how computers work, how protein structure is determined, and of course, why the Earth is an oblate spheroid. Yes, I'm sorry, flat earthers, you don't actually get to invoke the second law of thermodynamics, as your idea of the shape of the Earth is, well, you guessed it, thermodynamically unfavorable. Another useful description of entropy is as a measure of how spread out the energy is. For example, if you have a hot cup of tea on your kitchen surface, then the state has a low entropy at first, but the heat dissipates and spreads out, and then this becomes a higher entropy state. Now, for clarity, I am not actually referring to the entropy of the cup of tea. I'm referring to the entropy of your whole kitchen. Remember to set up your system correctly. But this leads us to another statement that is implied within the second law of thermodynamics. Heat cannot spontaneously flow from cold to hot. And this is the Clausius statement, or also one of the Kelvin statements. And Clausius and Kelvin's statements are equivalent. Also, please note that the word spontaneously is key here. Now, this is all a bit hand-wavy and vague, and I've been talking about how entropy is a measure of the energy that's no longer available to do work, and how it is a measure of how spread out the energy is. But let's have a look at the actual formal definition of entropy. Entropy is a measure of the number of microstates that can describe the macrostate of a system. Oh, well, in thermodynamics, a macrostate is a macroscopic measurable quantity like temperature or pressure. A microstate is a specific arrangement of the constituent parts of a system for the given macrostate. Each macrostate can be the result of several different microstates. For example, we have two dice and we roll them. A macrostate would be the sum of the results, whereas the microstate is a particular combination of outcomes for the individual dice that add up to that result. Take, for example, the macrostate which has a value of 7. Now, to make a value of 7, we could have one die which has a value of 4 and the other has a value of 3. And this is one microstate that can give that macrostate. But you can also roll a 5 and a 2 and get the same macrostate. However, the microstate is different. The number of microstates that can produce the same macrostate is called the multiplicity. Entropy is then defined as a measure of the number of microstates that can describe a given macrostate, and this is outlined with the equation where entropy S is equal to Boltzmann's constant multiplied by the natural log of the multiplicity. The second law of thermodynamics can be restated that as a large system approaches equilibrium, the number of microstates or multiplicity tends to increase. That is to say that over time, a system will end up in the macrostate with the highest multiplicity, or the most likely macrostate. But let's get back to Flervia, because here the claim is that the atmosphere couldn't stick to the Earth because this is a violation of the second law of thermodynamics. But the issue is that the second law doesn't say anything about how gas behaves. Again, a physical law does not describe a mechanism. The reason why gas expands into a vacuum is pretty simple. An object in uniform motion stays in uniform motion unless acted on by a force, and that is just Newton's first law. In this animation, I show a simple simulation of a gas in two separate pipes. Now, the pipe is open at the top and closed at the bottom. There are two barriers to create some compartments, and the particles in the bottom compartment have a random position assigned to them, and their velocities are drawn from a Maxwell-Boltzmann distribution. Now, when I run the clock, I will allow the gases to reach equilibrium, and entropy will then increase in that process until it reaches equilibrium. When I remove the first barrier on the left, the gas will expand, and this is because this barrier is no longer there to exert a force on the particles, and they drift across into the previously empty volume. The same happens when I open the second barrier, and the particles can now escape into the vacuum of this simulation universe. You will notice that I have a counter at the top, which counts the number of particles that remain in the pipe. But the pipe on the right has one key difference. Here, the potential energy of a particle increases linearly with height. When I remove the first barrier, the gas expands and entropy increases until that gas has reached a new equilibrium and entropy is maximum. But then I remove the second barrier and the gas barely expands. With or without this barrier, the equilibrium state is the same. Entropy didn't increase, as it was already at a maximum. The thing is that in this case, the maximum height a particle can reach is determined by the total energy it has. For it to go higher than that, it needs to gain energy. So yes, it is the conservation of energy that prevents the gas from escaping into the vacuum. I will preempt some flat earth derp around this and how this is just a simulation and not experimental evidence. Well, funnily enough, this kind of resembles Blue Marble Science's experiment with the butane in a pipe. But let's revisit the second law of thermodynamics, which states that entropy of an isolated system can never decrease over time and is constant if and only if all processes are reversible. Isolated systems spontaneously evolve towards thermodynamic equilibrium, the state with maximum entropy. You see, the simulation universe is an isolated system, and the gas did evolve towards a thermodynamic equilibrium, the state with maximum entropy. But as potential energy increases with height, thermodynamic equilibrium, in this case, it doesn't mean that the gas had to spread out evenly over the simulation universe, as was the case with the pipe on the left-hand side. The pipe on the right-hand side resembles the situation that we observe on Earth. I don't have to invoke gravity or any theory along those lines. All I ask you is to recognize that you have to put effort into picking something up. But it doesn't take any effort to drop something. It doesn't matter why that is the case. The mechanism isn't important right now. Let's just call it an empirical law. If you recognize that this is true, then you cannot argue against the situation on the right-hand side. And there is something else that becomes apparent. If you recognize that it takes effort to lift something up, then a big solid dome is not even necessary, regardless of the shape of the Earth. Of course, you will still need to explain why energy is increasing with height, but I will leave that as an exercise to flat earthers. The point is that for all intents and purposes, the atmosphere around the Earth is already in an equilibrium state. So as far as the second law of thermodynamics is concerned, the entropy is already at the highest it can be. But there's another very simple problem that flat earthers will run into, and that is their simplistic application of the second law of thermodynamics. Ignoring the fact that fluffs treat it as a mechanism rather than a constraint, the second law talks about isolated systems. The Earth is not an isolated system. It is an open system, or a small part of a much larger isolated system, i.e. the universe. The second law talks about the total entropy of the whole system, but locally, entropy can decrease, and that is perfectly fine. If it couldn't, then a refrigerator wouldn't work, and we would all live in a world without cold beer. But the second law of thermodynamics is satisfied by the fridge, as the process of cooling the beer results in heating somewhere else, and the entropy of the whole universe still increases. So when it comes to the flat earthers' claim that the atmosphere would escape into the vacuum of space, you just have to remember that the conservation of energy prevents that from happening, and the atmosphere is already in an equilibrium state. As far as the atmosphere contribution to the total entropy of the universe is concerned, it is already at a maximum. So yeah, okay, I'm pretty sure that you can tell that I picked Mitchell's video just so I could stick all that stuff in, but as there is more of his video, I will just randomly interrupt Mitchell's video to make penis jokes from here on.
Because most people still believe they are firmly on a rotating globe flying through space, and that is who SciManDan is targeting with this fraudulent image. So I'm going to break it right down for those people. The ISS is claimed to be falling around the Earth. This is not controlled flight or trajectory. It's definitely not in lockstep with the claimed rotation of the Earth, like globers say that planes, balloons and drones are. There is no doubt that the ISS is not in the rotating reference frame of the Earth. It is in the inertial reference frame.
But it is in the rotating reference frame that is stationary with respect to the observer on the Earth. However, it is not stationary with respect to that observer. As I've already said, you cannot leave or enter a different reference frame. A reference frame is just a mathematical construct. I know I said that I would randomly interrupt with a penis joke, but the only one I can think of so far is rather unfunny and pretty vulgar, so bear with me.
Globers claim that star rotation is due to Earth rotation, but the ISS is not in the rotating reference frame, so the ISS should never, ever see any stars moving. It's in the inertial reference frame, remember?
Mitchell, what you are looking at are star trails due to barrel roll. If you were to place a camera on a rotating platform and took a long exposure image of something whilst the platform is rotating, you are going to see these characteristic paths. And you almost demonstrated this in your previous video, but the same principle applies. Oh, and penis joke.
So seeing any star trails from the ISS is absolutely impossible. Right, Sleeping Warrior?
SciManDan.
Wow, I didn't even need to interrupt the video here. Looks like Mitchell brought his own penis joke. You know what the best part is? I didn't even plan this.
You cannot have circumpolar star trails from the ISS when they're in the inertial frame of reference. That's the thing that proves the Earth is turning. Because when you're turning on the Earth, we're told that the Earth is turning. That gives us circumpolar star trails. When you get off the Earth, even just by a few centimetres, that's supposed to stop. So when you're in the International Space Station, you're going to be orbiting the Earth. You're going to get linear velocity. But you're not going to get circumpolar star trails. Explain that, matey.
Oh no, Sleepy. When you are in orbit, you are following an ellipsoidal path. You are not talking about linear velocity. Angular velocity is still key here. As the ISS is in orbit, there's an acceleration towards the center of mass of the Earth ISS system. And guess what that means? A reference frame at rest with respect to the ISS is an accelerated frame, not an inertial reference frame. But you claim that as soon as you leave the surface of the Earth, even by 1 centimeter, you leave the rotating reference frame. And you also claim that once you have left the rotating reference frame, you can't see the star trails. Now let's ignore the outright fucking stupidity of that and take a look at this. Now, according to your statement, if we were to get these guys out in a field at night and attach a camera to the guy doing the flips and taking long exposures, there wouldn't be any star trails. After all, according to you, when he's doing that flip, he is not in the rotating reference frame. Bah! But of course, you will retort by saying that the guy is rotating and therefore he would get the star trails. But that is exactly the point of the image. The ISS does spin on its own axis. It has to do that to ensure that the same side is facing the Earth. All that is to say that a reference frame, at rest with respect to an observer on the ISS, is a rotating reference frame.
These points alone debunk this image. But to go any further, we need to beg the question that there is a globe and the ISS is travelling around it at 17,000 miles per hour, which is one orbit every 90 minutes. But by judging by the length of the star trails, it would have taken over an hour to get this footage, by which time the ISS should have completed almost a full orbit of the globe. There is no way those stars are still going to be in the frame of the camera by the time the ISS gets all the way around the other side of the globe.
Now here you say,
which is one orbit every 90 minutes.
The ISS rotates about its own axis every 90 minutes as well. And this is basically to emulate tidal locking, so the same side always faces the Earth. So let's have a look. We take this point here as being on the axis of rotation. We draw a line from that point to one end of the star trail. We draw another line to the other end of the star trail. We then take the indices of the pixels and calculate the position vectors of the starts and the ends of the trails with our first point as the origin. Then we just compute the angle enclosed by these two vectors. Considering that its rotational frequency is 1 rotation per 90 minutes, we can say that it rotates 2 pi radians every 90 minutes. So we divide the angle by 2 pi and multiply by 90 to get that this exposure would require an overwhelming 5 minutes and 17 seconds.
But what else can we see in this image? Well, let's look at the ground. There are some very clear, distinct lights. Whether they're cities or lightning, they are still motionless, but right next to them and running through them, there are light trails from the ground. Remembering that this footage had to be taken for over an hour, covering the majority of the globe's surface, it's not possible to have those stationary lights there, right next to light trails.
Oh yes, it is also worth mentioning that this is not a single exposure. You can see from this region here that this is a stacked image, not a single exposure.
So does anyone still believe that this image is real? Well, the lies don't stop there from SciManDan, because look down the left-hand corner. There's even plane trails. Yes, plane trails from 250 miles up.
It's funny how flat earthers complain about the lack of satellites appearing in images from the ISS, but then when there are some images, you get their shit. But this also ties in with the previous point. From these trails, you can clearly see that this is not a single exposure, but rather a stacked image. If it were a single exposure, then this line would be continuous rather than dotted. Anyway, that was it. I like Mitchell's videos. His videos are short and therefore not so tedious to get through. Now, I hope you enjoy that, and I would like to thank my patrons, and you know who you are, and you're well aware of how awesome you are. And of course, thank you all for watching, and until next time.